Before we begin working on this example, you may want to pause it, read it, and familiarize yourself with the problem. Now that you've had a chance to read the problem, let's create the piecewise function that we're going to use to model this scenario. Now, they do want us to define the function as h, depending on the number of years of building in this new housing plan. We're going to have two clearly delineated parts. We're going to have the work that they do in the first 6 years, and we're going to have the work that they do after those 6 years. Now, it might make sense right out of the gate to limit this a little bit. We're going to talk, once we look at the graph, we're going to talk a little bit more about how to limit some of the other parts of the graph, but right out of the gate, it should make sense. There should be a spot that you're already noticing where it would be good to limit, and that's at the low end. We certainly don't want the number of years to go down into the negatives, and we're okay if it equals 0, because if this contractor decides to not build the housing plan, then no houses will be built. Maintaining the rate that they asked for the first 6 years, if we build 4 houses, if they're capable of building 4 houses every year, then we simply have 4x. 4 is our rate of change, x is the number of years. As a year goes by, 4 more houses are built. Once we get above the 6th year, though, we have that rate change. And that rate change is only going to apply to those years that are beyond the 6th year. 8 is our new rate, and we only want it to apply to the years that are beyond the 6th year. This part of the function must also compensate for those houses that are already built. If the 6 years had already gone by, then that means that 24 houses were already built. 4 houses a year for 6 years. So if we're using the second part of the piecewise function, we need to make sure that we have those 24 houses accounted for. Otherwise, it's going to be like the contractor is starting over in the 7th year. They won't have had all of that progress that they accrued up until that point. Now let's look at the graph of this piecewise function. You'll see that we have our first line segment in red. That's the section where the housing contractor is building 6 houses every year. And it's after the 6th year that we switch over to the other line. The rate increases, the line segment gets steeper, but we already have that 24 that we've already built. If I left off that 24 and did not have that as part of the function, this graph would move down considerably, and it would look like I was starting over after 6 years. Now, this graph has some serious limitations to it that need to be addressed. First, it is unlikely that you are interested in all of these points in between. How many houses after 2.57 years? How many houses after 3.47? How many houses after 8.48 years? We're not necessarily so interested in those in-between points. Maybe we're interested in the halves. How many houses would be built in half a year? Lots of businesses do their work in quarters. So how many houses would be built after X number of quarters? But really, we don't need all of those individual points in between. We include all of them because we understand that this is a more generic representation of the situation. We don't want to limit ourselves to just having to plot point after point after point. So that's limitation number 1. Limitation number 2 centers around the domain and range. If I was to zoom out based on the way that this function is written, it is incredibly likely that you will assume that this contractor can just keep building houses for as long as they want. So if I'm to zoom out way out to this point out here, I'm talking after 56 years, we have a total of 424 houses built in this housing plan. There are some big housing plans. It is likely that they do not have 424 houses in them, and it is incredibly likely it did not take 56 years to build them. So every time we graph like this and we use the descriptor that's in the problem, we use the description that was in the problem. It said after 6 years, 8 houses are built every year. We have to be conscientious enough that we are probably going to have to be the ones to put a ceiling on this. And that's the kind of decision that would be made at the beginning of the building process. They would know, for example, that they could only build 100 houses, or that they could only build a certain number of houses. So let's put a cap on this and let's see what happens. Let's say that we are only able to build 100 houses. And it looks like it should take about 15 and a half years to build 100 houses. If I use a horizontal function, I can add that to my graph and say that that's the point where I have reached my upper limit. I can limit my graph work and say that that is where I'm going to be done. Now, obviously, I don't need this part to the left, so I'm going to add in the constraint that that's only going to start when x is greater than 15.5. If I really want this to maintain the fact that it's a function, I'm also going to have to relimit my blue line and say that, sure, I can be above 6, but I definitely want to stop building after 15 and a half years. And I'm the one who has to put that limit on it. I have to look at this graph and understand that it was limited in the valuable information that it was actually giving me. And that once I know, for this example, how many houses are going to be built, then I can have the conversation about where to put that cap. But I put that cap in there to say that this function is not going to extend beyond that point. So realistically, what does that mean? Well, it means they're done building houses. There's not going to be any more houses laid onto the property. So if the question was, how many houses are they building? Then the answer would be 0. But if we were extending this to just say how many houses are in the housing plan, then this would be a more accurate representation of the function.